In the previous video, we saw what the energy of a battery is, which is measured in watt-hour, and the power that a battery can deliver, which is measured in watts. So what is the capacity of a battery? When we look at a mobile or a car battery specifications, they say that the capacity is, for example, 300 milliamps hour or 300 amperes hour. What does this mean? With the capacity of a battery, we are referring to the stored electrical charge, which at the moment does not move. Remember from the video of what a battery is, when we said that the current in amps is the charge that crosses a fixed area in 1 second. This is amp equal to the charge in coulombs divided by second, or in an equivalent way, the total charge in coulombs is equal to the current multiplied by time. Charge equal to current in amps multiplied by time. If we use hours for the time, the net charge is amps per hour. This is the capacity of the battery. If we get back to the water reservoir and the dam, we will understand it perfectly. If we talk about battery or reservoir capacity, we are referring to the number of liters of water that fit in the reservoir. Therefore, we can link the electric charge in ampere hour to the liters we have available to perform work. Another example, if we use, for example, a tank of a normal car with a combustion engine, with the capacity of the battery, we are referring to the number of liters of gasoline we have in the tank. The kilometers we drive and the energy in watt-hour we consume will depend on how we drive, faster or slower, with more accelerations, less, for how long, etc. If we get back to the principles of battery operation, we are referring to the number of lithium ions that we have inside the battery and that we move from one side to the other, from the cathode to the anode when we charge the battery, and from the anode to the cathode when we discharge it. This is, we can relate the battery capacity to the maximum amount of work we can ideally do, but we are not using, and to the maximum amount of energy we can convert, but we are not actually converting. How much we indeed use it and how much work we do will depend on how we use it. This is, how long we keep the battery on and how much current we let out. Therefore, energy watt-hour, capacity amperes hour. How then we relate one to each other? We said that the capacity is related to the stored electric charge, the number of lithium ions we have inside the battery. In the case of the dam, the number of liters of water we have stored, or in the normal car, the number of liters of gasoline we have in the tank. These charges or liters can perform work for us. They can make a turbine move and produce electricity when it falls, or they can make the car move. Through this work, we convert the stored charge into energy. How? From the height of the dam from which the water falls, or in the case of the battery, through the voltage that exists between the electrodes of the battery. If I multiply the capacity in amperes hour by the volts, I have the maximum available energy stored in the battery. This is watts hour equals to volts multiplied by amp multiplied by hour. How can I then use this energy? If we now open the reservoir gates and let out a flow rate of 200 liters per minute, we are referring to the current in amperes flowing out of the battery. Remember from the video on power. Power is the multiplication of the water flow rate by the height from where it falls, or the current multiplied by the voltage. Remember that this power is equivalent to the work and energy we can do or use for 1 second. And the energy we have used from what was available, which was the capacity, is the power multiplied by the time we have been using it. And here we have the first compromise or complication we have in the battery world. What if we want to generate a lot of power and at the same time maintain it over time to supply a lot of energy? Let's look at it another way, by analyzing the motion of a car. We know that mechanical work is equal to force multiplied by displacement, and from the Newton's law we know that force is equal to the mass multiplied by acceleration. So therefore, the energy consumed is the mass of the car multiplied by the acceleration multiplied by the distance it travels. If the available energy is the same, which is limited by the capacity of the battery, if we accelerate it more, with the same energy we travel less distance. And if we want to travel more distance with a charged battery, we have to accelerate less, demanding less power from the battery. We'll see this in more detail in the following video, along with the implication for battery design and manufacturing.